Sljedeći predavač isto je prvi put na ovoj konferenciji, vjerojatno ga ne poznate. Najavio je exploit za Rimac automobile. Toni Mirkiša Sondi, Breaking Internet of Things. Dok se on spremi, dvije zanimljive informacije. Imamo preko 1200 gledanja streama, što je barem za nas organizatore šokantno. Mi smo očekivali tipa 50-100 ljudi će nas možda pogledat, što je daleko iznad očekivanja. Uz ovih 300 ljudi koje je došlo kao posjetitelji, ovo je stvarno fascinantno. To je sadašnja informacija, a do kraja dana će vjerojatno biti još. I još jedna zanimljiva stvar, da ove godine, osim što imamo najviše stranih predavača, imamo predavača iz 10 zemalja. Znači imamo predavače iz Njemačke, Italije, Turske, Bugarske, Mađarske, Švicarske, Albanije, Nizozemske, Grčke i Hrvatske. Ovo je apsolutni rekord I Francuska, pardon, onda 11. Super, hvala. Toni, jesi spreman? Moramo čekati da se MacBook zbuta. Jel dozvoljavamo Macove? Može. Da, zanimljivo. Mislim da nije jedno Windows računalo kod predavača nismo imali ove godine. Bar ovdje. Toni, izvoli.
Aha. So, hello everybody. My name is Toni Mirkiša Sondi and I head the Open Systems and Security Lab at the Faculty of Organization and Informatics. And my current topic will be breaking the Internet of Things, because it's always easier to pick on the little ones, right? So, first thing, a disclaimer. My research is sponsored in part by the Croatian Science Foundation, and it is connected to a project we are doing. A small part of that project is security, and the project name is Internet of Things Interoperability Framework. You can see more at iot.foi.hr. So if you're interested, just check it out. Also, I decided to try out the Google Presenter view, where you can ask questions anonymously or under your real name and avatar on this link upstairs. I believe this will be a big problem, right? So, the first question before you enter any lecture is, why should I be here and not go out and get a cup of coffee or a beer or something else? Well, Internet of Things is the next big hotness. Everybody is trying to crowdsource some smart object, smart thing, running on something either GNU Linux based or something like an Arduino. It's cool, it's fun, it's simply something new. And there is a problem. As a security researcher, my point of view is it's like the 90s of information security, but with gadgets and startup mentality. Just ship it out as fast as possible. Doesn't matter if we have any security or not. So if you're interested in embedded hardware, in stuff running Linux on embedded devices or in the Internet of Things, maybe you should listen to this. The second thing is that the Internet of Things mentality is here to stay. All kinds of manufacturers, from refrigerators to TVs. TVs are starting to run Android. Refrigerators are starting to run Android or Linux. Seriously, you can root them. You can do all kinds of interesting stuff on smart fridges. Like locking them in and not letting yourself open them. The second thing is that Internet of Things is a network of physical objects connected into a wider network. Usually there is a mobile application somewhere, there's a cloud component, there's a server component, and the marketing speak for IoT goes something like creating opportunities for a more direct integration of the physical world into computer-based systems, resulting in improved efficiency, accuracy, and economic benefit. What it means in practice is that, well, we start to get Bluetooth-connected toilets. So it's called the Rain, like the reign of a king, right? It has Bluetooth in it. When you come closer to it, it will open, release some perfume, start a relaxing piece of music. It will wash you, it will dry you, and it even has a heated seat, like a Mercedes-Benz. It actually is the Mercedes-Benz of the toilet seats. The problem is, sounds excessive, right? But it's the new hotness in Japan, seriously. The negative thing happens when you get some security researchers, like those from Trustwave Spider Labs. They gave them a toilet like this, and guess what happened? Since it runs Bluetooth, it has zero security. They managed to spoof the connection to the toilet seat and to spray people with water. And, well, not the kind of music to play the music people wouldn't like and so on. So it is really interesting because it's a mentality where we get all kinds of software and hardware and zero security in it. It's not really, it's more of a fun thing, but there are lots of things that could, for instance, be more disturbing than a toilet seat spraying water on you. Like the new Android smart TVs and Symantec's research on that actually people started doing smart TV ransomware, which means you install an application, your Android smart TV gets a ransomware malware on it, and you need to pay some amount of Bitcoin in order to use your TV again. Then it starts being funny. Also, it starts being funny when you get one of these. It's a fitness tracker. Why would I need a fitness tracker? You see that there's no use for it, really. But the point is, I started looking up what do they do actually. They measure heartbeat, they can measure galvanic skin response, how much you sweat, they can measure your sleeping cycles, and I thought it must be very sophisticated, I can probably hack something out of it. And I figured out it's just an accelerometer, a couple of sensors, a data logger over serial, and a Bluetooth serial connection. They're as simple as they get. And first thing I did was connect my this Bluetooth thingy to an intercepting proxy over my machine and start collecting data. I want to see what kind of firmware it has. I want to disassemble its firmware. I want to see what kind of data does it send to the company. But I was smart and security savvy, right? I'm not a usual user that will just click next, 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 next. I'm the kind of guy that goes, privacy, yes, do not send data, do not send this, do not send that. I wear it 2 days. Check out my application, what does it contain, how much did I sleep, how much did my little kid wake me up, how many times during the night. And as I was intercepting everything, I figured out something funny. First thing, it doesn't send data to one vendor, it sends data to all kinds of vendors. Second, it sends all kinds of stuff, from your height, your weight, what you entered, how many times did you wake up, your resting heart rate, what's your heart rate when sleeping, what's your heart rate when running, and everything else. So, fitness trackers are really cool, and those smart lifestyle accessories, but they share that data with you. And it's more personal data than what kind of websites you visit and what kind of categories do you like on those websites. It's far more personal because it contains your health in it. And it starts being funny when you have, for instance, health insurance, somebody buys that data and says, okay, let's cancel his health insurance because, well, he is going to probably have a stroke in 3 months or 6 months. And it starts being funny. And you know what else isn't funny? Companies that start to sell data, to collect data, and start doing something called influence-based marketing. How can I influence my customers into doing what they want? There are companies that do this, and what you have to be aware of is that those companies buy data from fitness trackers, they buy data from all kinds of devices, and they will use it for profit, right? So be mindful of what you share. It's a little bit different than on this conference. This is a news image for today. The FBI cannot confirm nor deny that they wiretapped an Amazon Echo in an investigation. And I thought, wow, so the FBI started tapping smart things in somebody's house, like a smart hub. And then a friend sent me this, like, thank you, Vedran. He sent this half an hour ago. So it's, how is a big Zaba is a big bank company in Croatia, and it says, how was a bank heist stopped? The police tapped into a smart TV from a couple of suspects. They had a warrant to tap their smart TV, and with that, heist of a bank was stopped. So this is in Croatia last year. I don't know anything about this. This is half an hour old, but it really sounds interesting. So it's not we're going to wiretap his phone. It is let's wiretap his smart house. And that's a problem, because each element in an Internet of Things ecosystem, like your TV, your toilet seat, your smart home, your smart bulb, your refrigerator, your stove, your microwave, if it's IP connected, it can be hacked, and usually the effects can be really interesting. So what's an architecture of an IoT ecosystem? We have a thing. A thing is usually an embedded device, something which is connected to either a mobile application or a network service somewhere, either locally or in a cloud, or either connected to another thing in a peer-to-peer. There are lots of different types of protocols, like wireless, like XB, Zigbee, Bluetooth low energy, all kinds of protocols, even some embedded ones that most of you didn't hear of, or I didn't hear about them, but they usually don't have too much of a security issue. Like Bluetooth, the original one, was pretty okay, not spectacular, but it was okay. But the Bluetooth low energy version has serious issues, like you have a tool for cracking of BTLE encryption called Crackle. If you have enough data, you can use something like Crackle to obtain the plain text data. Also, the Open Web Application Security Project started going into the Internet of Things top 10. So it started from, I think it's HP Fortify Labs. They analyzed some things, and they came up with this list. It's what are the most serious problems in Internet of Things? First, insecure web interface. What does it mean? You have an embedded router, you have your embedded fridge, it has a web interface, and most of the times it was written by systems developers that are developing an embedded system. It has a web app that usually does system or shall execute something. Most of the times it's calling binaries, it's calling scripts, and it's calling them as root. So pretty much you own one device, you own them all. Second thing, network authentication, authorization. Most of the times it is, you can have a lot of default passwords. For instance, in the faculty we bought a smart gadget, and here's an IP address. Me and a friend were joking around with it, and we found out that it has a default password, like default no password. You can enter it and you have a limited shell, and then you need to escalate to root, and we'll talk about that a little bit later, how you can simply escalate to root if you're just looking at it a little bit. Insecure network services. When you have an embedded thing, the network services are usually ancient. It won't use SSH, it will use Telnet. And any other type of network service, like Samba, if it has a file and network sharing part, it will be a couple of versions older, and usually you can find vulnerabilities in those embedded services. Lack of transport encryption, integrity verification. Usually the protocol is encrypted. For instance, they have some kind of security, but the other thing is that people don't think about replay attacks. What happens if I replay the data? What happens if I just throw junk at it? Will it change something? There was an interesting attack with garage door openers, where a guy called Sami Kamkar discovered the usage of De Bruijn sequences in order to faster brute force the door opening login check. It's not a login, it's actually a code check where it checks with the help of a linear shift register. You can look it up, Sami Kamkar, Open Sesame, if you're interested in hacking a door in a couple of seconds. Privacy concerns. It is still not really known. The data privacy concerns in IoT are big. All kinds of data is collected. God knows who uses it. Most of the times there are multiple vendors that are receiving that data simultaneously from a thing. Mobile and cloud interface, absolutely, the security is horrendous. You have no security configurability. You cannot disable a service. You cannot say, I don't want to use Telnet, I want to use SSH. You cannot say, okay, I want to change the web interface. And usually firmware is horrendous and the poor physical security to up that. I'm just going to go to the bottom of the list and do the poor physical security part. And we're not interested in the whole ecosystem, because That's a problem. The whole Internet of Things ecosystem is so complex. We have mobile applications, mobile devices. We have web. We have cloud. We have a thing. We have software or firmware running on the thing. We have multiple types of protocols, and usually we have 3 people in a garage working on their next Kickstarter project, right? So you can think why this is a big problem. So what's the attack surface for a thing? There are a couple of things you can do. Usually if you have physical access to a thing, you can manage to do a couple of things. First one is, can you obtain system access? And by system access, I mean, I want a root shell on that thing and I want to do whatever I want with it. Second thing is, if I can't get a root shell on it, how can I see in what ways can I get a root on it by analyzing the firmware, the software, or something else. And the last one is software and firmware vulnerabilities. What I won't cover is software analysis, because that would be reverse engineering, that would be web application security, that would be binary analysis, depends really on the device. I won't be covering radio and RF analysis, because that's a topic for itself, and you can do like a series of talks on just that. There's a lot of other stuff that I didn't cover, but if you're interested in this topic, just say, hey, I'm interested in that and we'll talk. And we're looking for easy victories. And by easy victories, I mean any one of you that can hold a screwdriver and can know a couple of things, how can you hack your next thing? Why am I doing this? You know the old saying, why? Because I can. But the real scientific background of this is, how do you measure a security of a thing? For instance, for web applications, we have the OWASP ASVS, Application Security Verification Standard, which will say in one of 3 levels how much a web application is secure. We have the OWASP testing guide, which will tell us how should we test a web application, or OVTF. For Internet of Things and Embedded, we don't have that kind of stuff. We don't have a verification standard. Okay, what do I need to do to make my thing secure? And that's what I'm working on currently. So if I can hack stuff by doing it, so much the better. And the third thing is, the IoT top 10 was based on, I think, 10 devices. So they analyzed only 10 devices for the IoT top 10. I'm looking to see if it's really relevant, or if there are more devices that can shed a more clear picture. So the question is, how can I get started? Do I need thousands of dollars of gear? No, you just need a couple of things. Usually it comes to that you should just get a Bus Pirate or a Shikara, which is a $30 device that you can buy on eBay, or a clone from the Chinese, and it's a great little thing. How many of you have a Bus Pirate at home? Now I know how much of them just do hacking. So there are a couple of other things you can use, like an FTDA cable. You don't need it because the Bus Pirate is an UART adapter. You won't need it, but sometimes it's practical. You don't have to configure the Bus Pirate. You just stuck it in and it works. Easy hooks, I'm going to show them later, for tapping into integrated circuits, SOIC clips. You don't need all of that. You can just put it on the minimal level and going under $50. If you want to do radio analysis, there is lots of cool RF analysis tools. Is anybody interested into hacking RF? Okay, coffee later. So there are lots of firmware, software-defined radios like HackerRF, like Ubertooth, like Yardstick One, RFCat, which are all $100-ish, which you can use to hack radio. And if you want to analyze JTAG, either do, how should I say, trial and error method, or get a JTAGulator, which will show you the JTAG layout on a board. But you don't need that, because honestly, I tried to play around with the JTAG, and usually you don't have the need to. There are way more flexible methods you can use than playing around with JTAG. So why should I hack my smart blob, smart fridge, or something else? There are 2 reasons. One is you want to jailbreak it. If your smart fridge runs Android and it runs a full version of Android, why shouldn't you play YouTube on it or something else? The second thing is security analysis. I want to know, if I put a thing into my network, what's the security level of it? Can somebody remotely access it? Will somebody be able to remotely access the thing and get into my network? So am I actually putting backdoors into my network? Things that concern me are security set credentials like passwords, which are ripe in the Internet of Things space. GPG signing keys and passwords in the firmware updates. If you think that's Jesus Christ, who would send a GPG private key for the firmware signing inside their firmware? Think Belkin Vimo. They did that. Third thing is, you can get full access to binaries, web applications, anything. And if you have that, you can usually analyze it. If you have a source code of a web application, you can start digging for vulnerabilities. If you have a binary, you can reverse it. You can do all kinds of stuff. And usually, all of that is written by electrical engineer developers. I'm not saying they're that as a demeaning thing, but they're experts for electrical engineering. Usually, they don't have the awareness for security issues. So we need to work on awareness. Nobody is stupid, but people need to get aware about security issues in the stuff they develop. So, pictures, pictures, pictures. What do we need? We need to get UART access. How? Find a UART port, which is actually a serial console on a device, connect to it, get a root shell, I don't know what, and then profit. How do we find UART ports? What are UART ports? It's actually 3 pins: ground, transmit, and receive on the device, which will enable us to connect to a serial Linux console or any other type of console that's running on that machine. How do you find them? Well, there are a couple of ways. Using a multimeter, just find the ground first. After ground, use a logic analyzer, your eyes, or a beeper. I love the beeper part when you just connect it to a pin and see if the audio level changes. If you hear it beeping differently, then you know you hit something that's sending data. The third one should be, I don't know, receive. You see the little 4 pads? They're practically labeled. Transmit, receive, 3 volts, and ground. You just need to connect the transmit, receive, crossed over, and a ground one. Sometimes they're populated. 3.3, receive, transmit, and ground. You have to figure out which one is the transmit one first, right? The Raspberry Pi, if you have a Raspberry Pis, and you're always angry, why do you need a monitor to connect to it and configure it? In the GPIO header, there's a serial console. You just get a serial cable, connect to it, and you'll get a console. You don't need a monitor, you don't need network access to it, you just use a serial console to interact with the Raspberry Pi, which is really practical. Sometimes you just get 3 pins. Sometimes you get micro pads that are extremely small. You can see a small microchip pad. It says TP out, TP in, wing it. An oscilloscope is handy, but we won't be covering that. Just use a multimeter if you want to see if there is a signal change. Just connect a beeper to it and you'll see if the audio level changes. You'll know it's the transmit pin. You need a common ground, but in this case, you can just fetch ground from a chassis of a new USB port or something. And connect it to your bus pirate, which you will configure in a UART bridge configuration, or to a UART cable. And what after that? Yay, we can see the bootloader and we can see the kernel booting. Usually, you'll see something like that. That's a boot log from a Unify access point. And we can press a button to hit any key to stop autoboot. And we can stop the autoboot process and issue a command like help. You'll find out a large number of commands like dump memory, which is also really useful. But one I'm really interested in is print boot environment. And we can see here boot arguments console tty0 panic tree. Does anybody know what do we need to do if we cannot access the device? You know the old boot init bin sh trick? The kernel init hijacking trick? Set environment, the same thing. Init is bin sh. You know from the old days of booting into grub, editing a grub entry, and then just saying for the kernel init file, it's don't run initrd, just run bin sh. Save environment, boot, and you pretty much get a root shell. Simple trick, but that's the advanced version. Usually if you connect to a UART shell, 75% of the time you'll just boot into a root shell, so no need for that. And if you don't, if there is a login, usually you can use this to bypass it. There's also a cool thing called non-glitching, which I won't cover now, but if somebody is interested in glitching memory, just hit me up. I'm more than happy to explain it. So what are the other options we can do? There are a couple of other options. One is you can fetch an image of the vendor's page. If you just go to support, download firmware images, download the firmware image and analyze it. That's also good because a lot of vendors like Ubiquiti have bug bounties, not small bug bounties, but large bug bounties. And if you have a firmware image, you can analyze it on your machine. You don't have to have a device. You can probably find vulnerabilities in there. Second, if you have a smartwatch or something, you can't download the firmware, well, you can intercept it with an intercepting proxy like OWASP, ZAP, or burp, or MATM proxy. Third one is you can do a dump of the memory with the help of your bus pirate. Plan C.5 is you can unsolder a chip, the flash chip, put it in a reader and then read it, which is way more complex. You can use JTAG, which is also you need the JTAG adapter, blah, 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 more complex. Or if it's an Arduino, plug it in, and you can just use AVR dude to dump the contents of the whole Arduino to your machine and then analyze it. It's pretty simple. Google Bus Pirate Flash ROM. There's a tool for reading and writing flash files. It supports the Bus Pirate. You'll get a handy pinout how to connect each pin to the flash chip, and then do something easy like flash ROM. It's a Bus Pirate this speed, and read the file into this here file, and you just get a whole flash image dump. The problem is that most of the people think, oh, I'm going to get partitions. No, you're not. You're going to get a flash image, which means you will get a bootloader, junk, everything, partitions, all kinds of stuff thrown in. So you have to analyze it later. We'll be talking about this in a minute or two. If you see something like this, TCCage, RST, TMS, TDI, TMO, TDO, and so on, you know it's JTAG. I won't be covering this for time's sake, but if you're interested in it, just ping me. There is other ways to tap stuff like pogo pins, but the time. So what's the useful software here? First, you have something called flash ROM, which will enable you to read them. Second, there is OpenOCD, which will help you with on-chip debug, I mean JTAG. And third thing, there is in QEMO. Some images can be run in QEMO. You can Google it out. If you have a raw image for a file system or a Linux machine, a MIPS machine, most of the times you can use QEMO to boot it and then just see what it does in your own machine. That's the stuff I was talking about. And I got a firmware image. What now? I downloaded it from a vendor. I used flash ROM to obtain it from a board. What do I do now? There are a couple of cool tools you can use. First one is binwalk. Binwalk is a really simple tool. You just use binwalk an image of a flash file. It will carve the file into partitions, into files, into binaries, all kinds of stuff you can find out. Sometimes, most of the times you'll find something like squashfs. And most of the times you won't be able to unpack it because it uses a proprietary form of compression or something like that. There's a cool tool to mitigate that called Sasquatch. It is practically squashfs tools, but with certain patches to enable XZ decompiling and so on. For instance, there is a popular telecom in Croatia, which I won't name, which uses a popular brand of Chinese routers, which I won't name, and you can download a firmware image, but you cannot unpack it with binwalk. Why? Because they use a special type of XZ compression. I don't know what's the difference, but a Sasquatch can detect that, and it will normally decompress the whole image. There is a third tool called Firmwalker, which will you will get an unpacked firmware image, and it will walk through the firmware image and dump all interesting things, like user accounts, like SSH keys, like certificates, like all kinds of stuff that could be interesting for a security review. So the last thing you can use is your eyes, because you have an unpacked file system, just look over it. So this is an example of a binwalk output. You can see it's pretty much simple. You just do binwalk and the binary name, and it will say it's a squashfs file system. There are a couple of scripts. There is an ELF file. There's a Unix path here. There's some XZ compressed data, and if you just tell him binwalk -e, it will extract everything into another folder. And you can pretty much then just enter that folder and look around it like a normal file system. So if you know how a Linux file system looks, you're pretty much on your home ground right now. You can just enter etc cat password, cat shadow, and you'll get the accounts. You can check out the etc directories. You can check out the opt www for the web pages and so on. It's pretty much simple. More interesting is when you find certificates. Well, it does say the vendor, too bad. So you can find certificates in there, which are usually private keys, and with private keys that are deployed all over the same set of things, you can practically mend the middle connections. That's the problem. Vendors do not rotate their keys on various devices, and by compromising one thing, like one smart fridge, you can pretty much hack then all other ones because they have the same set of keys or the same set of credentials. Usually routers are notorious for it. You can find like 4 or 5 different accounts which you can use to access other routers unlawfully, right? For instance, cameras are fun because they're also run Linux. When you hack cameras and you have remote access on them, you can do, well, interesting stuff. It's all pretty much, as I said, really old versions of Linux and with really bad security. And for instance, if you get a firmware image, you get the ATC folder, you get the init, now you have a limited shell and you want to escalate. Most of the times you'll see something like that. Can somebody tell me the root exploit for this? All files are owned by root. All files are loaded at boot time. And all are world writable. You just edit one that's world writable, which one you like. You like the app, the demo, the network, and just add some commands you like add a root account and reboot the device and you're in. That's an advanced part. This one is from a camera that actually Mario got, and Mario and I were tinkering with it. And the interesting part was that we found the default password, we found big permissions on scripts. We didn't still analyze the web application part because that's the classic things that are not that really interesting, but usually you get it. If you have that kind of camera, one set of credentials gets you access anywhere. Firmwalker, just run it on a file system, you'll get all kinds of goodies out of it. You don't have to know a lot of things. You just need to know how to use the tools. There's a lot of other things like connecting to an EMC, like a multimedia card system on it. There is some devices actually have USB sticks on them. Just unplug the USB stick, put it in a machine, read it and edit what you want, analyze it. Some devices boot from micro USBs for power. For instance, the Chromecast had a micro USB connector for power, and that micro USB connector was actually USB on the go. So if you have a powered OTG adapter, you could boot from a USB stick and then compromise the whole machine. There is a lot of stuff I didn't cover. There's a lot of stuff to talk about here, but I misjudged the time. So what's the important thing? I'm closing with this. The Internet of Things fad is here to stay. Everybody's trying to do the next smart thing. Most of the stuff runs Linux. Before buying, inform yourself on the possible implications. From refrigerators, from cameras, from TVs, Android TVs, most of it is pretty badly vulnerable. So what's the moral of this? If you develop free open source software or hardware and embedded stuff, take note. Open by default is broken. Tighten your stuff. Make sure that you build security into the stuff you develop. And if there is another thing here. If some vendor wants to lock your device, for instance, I saw a lot of vitriol about certain router vendors locking their update mechanisms. There is no way to prevent people from actually getting to the firmware, dumping it, and editing it. It would be too much of a hassle to produce cheap devices that are locked. You can always get to the firmware, you can edit it. There are even tools out there that enable you to edit firmwares and dump them back into a machine. So don't worry. Just learn a couple of new techniques and you might have some other fun. Questions? I see 5 new questions on the audience tools. What is the average number of engineers needed to make an IoT device not crackable in one lazy evening? Good point. I would say that it's not really about the number of engineers, it's more about the awareness. For instance, web application developers, they usually say, those WordPress developers, they do bad stuff. I was like, no, they are simply not informed about the possible implications of their code. If you inform them, if you show them a couple of problems, they're like, how did you figure this one out? I was like, I didn't figure any of it out. Other people did. And they're like, it's easy to protect against this. Yes, do it. So it's not about the number of engineers. You just have to educate them. That's the point. It's not about, okay, we need to employ 5 more people to have extra security. No. Select user ID name, password from users where user ID equals stuck is a son or 1 equals 1. Oh, that's so sweet. Where were I? Actually, it worked. Right. Tools, continue recent, 15, 316. This one? Yeah. Yeah, why didn't I? Because I was not really smart. No, it's okay. I wanted to do that. So, any other questions?
Normal question.
Seriously, no more questions? I'm
Ima
disappointed.
još tamo, mislim.
Yeah, I'm trying to find where they are. That's the problem. Because I cannot get to them back. Too bad. If somebody has questions, I lost the questions from Google Slides, so...
Evo ima Željko.
Thank you. Would you rather fight a horse-sized duck or 100 duck-sized horses? Well, rather a horse-sized duck. It would make for an interesting story. What is my name? My name is Tonimir. What is your quest to find the Holy Grail? Any other questions?
Ima normalnih pitanja.
Unfortunately not.
Nema pitanja. Sve si zbrejko. Hvala Tonimiru, odlično predavanje.